Hi, and welcome to today's Daily Chronicle. Today is Wednesday, December 10th, 2025. Rising temperatures could have a chilling impact on young children. A Palestinian woman uses a plastic plate to fan a baby during a heat wave in Gaza in 2024. Young children really struggle in the heat. Their bodies are too small to cool down by sweating. Like adults, and their wholly reliant on grown-ups to find any kind of relief, be it air conditioning or shade or a cool drink. Now, new research points to a potentially lifelong setback for little ones exposed to extreme heat, which is becoming more common due to climate change. In a study of nearly 20,000 kids, young children who experienced hotter temperatures than usual were less likely to meet basic developmental milestones than those living in nearby but slightly cooler areas. Researchers report in the Journal of Child Psychology and Psychiatry, children in lower income households and urban areas were especially vulnerable. Early childhood is a sensitive period of development, says George Huertas, a researcher at New York University who led the study. If we experience excessive stress without a buffer, that can lead to long-lasting impacts on brain and skill development. As temperatures rise around the globe, researchers are scrambling to study the impacts on human health. They've linked the extreme heat to increased risk of heart attacks, anxiety, depression, and premature birth, says Cuartas. But there was nothing about early childhood development. In the first few years of life, we develop key physical, cognitive, and social skills that can shape the rest of our lives. Meeting these basic developmental milestones at the appropriate time, including being able to grasp objects with 2 fingers, recognizing letters or words, and playing independently, can influence later life outcomes, from mental health to economic success. Delays in developing these skills set kids down a developmental pathway that can affect not just individual well-being, but society as a whole, says Cuartas. To see if extreme heat impacted the development of these skills, Cuartas and his colleagues analyzed data for nearly 20,000 3- and 4-year-olds from Gambia, Georgia, Madagascar, Malawi, Palestinian territories, and Sierra Leone. These places collect data on early childhood development in similar ways and have detailed climate records, allowing the researchers to look for links between heat and development. Links emerged. Children living in areas where the average monthly high topped 86 degrees Fahrenheit at any time during their life were about 5 to 7% points less likely to be developed on track that children who lived in the same general area but experienced temps about 9 degrees cooler. Cognitive milestones, especially those related to learning to read and do math, were more likely to be affected than physical or social milestones. That may sound like a small change, but applied across a whole region, it's a lot of kids, says Cuartas. In their whole sample of nearly 20,000 kids, approximately 63% of children were developmentally on track. Reducing that to 5 to 7 percentage points in the study sample alone is about 1,000 children. Even a slight decrease can have a significant consequences for our society as a whole. Marshall Burke, an environmental economist at Stanford University, who wasn't involved in the research, agrees. The study is well done and the findings consistent with the growing body of research that shows that early life exposure to climate extremes can have really lasting impacts on health and livelihoods. The study cannot say how extreme heat is causing these delays, but there are several theories. Lots of research suggests heat can dull thinking and slow learning. That's consistent with their findings on literacy and numeracy, says Burke. Extreme heat can also raise the risk of violence within a family, according to previous research by Cuartas. Extreme heat can make parents more impulsive, irritable, and aggressive, he says. When that's directed towards children, it can harm their development. Heat can also mess with children's sleep, which is essential for growth and development. Or extreme weather could close off opportunities to learn and play, an important part of growing up. Maybe children are having more difficulties attending early childhood education and care centers. Or spending time outdoors because it's too hot, says Cuartas. Whatever the cause, the harms of heat were not evenly distributed. Children from lower income families, those who lived in urban areas, and those who had a harder time accessing clean water and sanitation were especially vulnerable, researchers found. Such children face more barriers to get away from the heat, says Lindsay Bogart, a pediatrician and chief science officer at the Center of the Developing Child at Harvard University, who was not involved in the study. Especially in lower income countries, they may live in a house without air conditioning, or their neighborhood may have a few trees to provide shade. Those barriers add up. You can think of it sort of like a seesaw, she says. Extreme heat can weigh hard on one side, but that weight can be offset. The study, she says, points to where we need to step in to protect children. Investments to ensure access to clean water is key. For example, and while air conditioning may not be realistic in many countries, there are other strategies. In terms of buildings and structures, shade is one of the most powerful tools, says Burgart. So preserving green space, planting trees, and planning development with heat mitigation in mind could help. Scaled up, such interventions could tip things toward positive development. A ban on feeding pigeons ruffles lots of feathers in Mumbai. Visitors to Mumbai feed pigeons near the Gate of India. The city's residents are sharply divided. There's the pro-pigeon feeding contingent and the anti-pigeon feeding contingent. The latter group were heartened by a government ban in July on feeding pigeons at designated spots in the city. After public protests, the ban was modified to sanction 4 locations for tossing grain to the birds. Mumbai. For the past 4 decades, Mumbai residents Premlata Soni and her husband have fed the pigeons that flock around a reservoir known as the Bandra Lake. Sometimes it's a few fistfuls of corn and millet grain, sometimes an entire bag. Even during the pandemic lockdown, Sani would sneak out to feed the birds. She sees it as part of her faith, a way of showing connection to the world around her. God wants us to do it. She says, God may want it, but Mumbai authorities do not. Pro-pigeon versus anti-pigeon. For years, the city has tried to battle what they see as the scourge of pigeons. A bird that has thrived in a city of skyscrapers by nesting in apartment air ducts and near air conditioning units. The pigeons have also found patrons in Mumbai residents like Sani. Pigeon feeding is seen as a pastime in this teeming port city of 20 million, to salve to loneliness a connection to the distant world of nature. Over the years, Mumbai authorities helped out too by marking out 51 pigeon feeding spots called kabutar khanas in the city. The Hindi word translates to a house or place for pigeons. In neighborhoods without them, people fed pigeons on pavements and at traffic intersections. Designated pigeon feeding spots in Mumbai were covered with large plastic sheets as part of a court ban. But in July, amid growing concerns over the number of pigeons calling Mumbai home, the city banned pigeon feeding in public spaces. Authorities fanned out across the city and covered popular feeding spots with blue tarpaulin sheets. They also put up posters warning of respiratory diseases that can be triggered by exposure to pigeon feathers and poop. The crackdown did not deter Soni. Where will these poor birds go if we don't feed them? She asks. Bikram Kumar, who guards the Bandra Lake, which is a Mumbai heritage site, says dozens of residents like Sani defy the ban every day. But he doesn't interfere. The last time he did, he says, one man punched me in the face. Feelings run high. About pigeons in multi-faith Mumbai. In part because for some communities, feeding them is a religious duty, especially the Jains, a community that abhors harming any living creature. Puran Dashi, a community leader, says the importance of pigeons can be traced to Jain scriptures, which say that one of their gods gave his life to protect a pigeon from a falcon. It's why they feed pigeons, he says, to honor his sacrifice. After Mumbai banned pigeon feeding, hundreds of Jains and bird lovers protested outside a popular kabutar khana and tore up the barriers. That upset some local residents, who said that Jains were asking for special treatment. Some critics even organized a protest against pigeons and the people feeding them. This disagreement over religious traditions has played a big role in the debate over feeding pigeons. Pradeep Samant is a secretary of the Marathi Ekigaravan Samiti, an advocacy group that champions Mumbai's largest ethnic group, Marathi speakers, for the surrounding state of Maharashtra. Pigeon is not an issue. It is only an entry point, says Samant. He also accuses Jains of being migrants, since most trace their roots to the Indian states of Gujarat or Rajasthan. But they are creating exclusive neighborhoods in Mumbai, not allowing people to eat or sell meat, and now endangering public health. Puran Doshi, the Jain community leader, rejects the allegations. He notes that Jains have been in Mumbai for generations. Mumbai is scheduled to hold its mayoral elections in early 2026. Both groups have warned they will mobilize voters around the issue of pigeons. In October, one Jain monk said his community will continue their fight by setting up a political party with a pigeon symbol. Soon after, the municipal authorities relented and said they would allow pigeon feeding in 4 parts of the city. The culture war over pigeons despairs. Ornithologist Mohammed Dilawar, he says the real problem is that there are just too many pigeons. This is called a human-induced population, he adds, attributing to pigeon feeding. It's not a natural population. A 2023 survey by Indian bird watchers estimated that a dominant rock pigeon species increased by 150% over 2 decades. But more pigeons mean more poop. There is a huge amount of economic cost to pigeon droppings, as they damage a lot of heritage and commercial structures, he says. Pigeons and pneumonitis. Then there's the government warnings about pigeons as a public health concern. Dr. Sujit Rajan, a lung specialist from Mumbai, had told a high court in the city a few years ago that pigeon antigen, a protein found in their droppings, could cause a disease called hypersensitivity pneumonitis. While the illness is treatable at an early stage, most people realize too late or report symptoms when they get more severe, by which time fibrosis has already started in the lungs. Court documents from July this year quote him saying, a 2019 study published in the European Respiratory Journal backs him up. It studied 60 Indians diagnosed with hypersensitivity pneumonitis and found that pigeon droppings were responsible for the infection in nearly 1 in every 3 patients. There are no drugs to cure or reverse fibrosis, Rajan adds in the court papers. Many of these patients require oxygen at home and often die suffering on ventilators. And while a lung transplant is an option, it is extremely expensive and fraught with complications and poor survival rates. Vaishali Chodanaker's husband died a few years ago after he was diagnosed with irreversible lung damage. She said that doctors believed it was likely because of the exposure to the pigeons nesting at their terraced apartment. Chodanaker now runs a foundation to help others with lung diseases to get early diagnosis and treatment. In India, any issue can get mired in politics and religion, says Chodanaker, and the main focus should be the health of the people. Bird love. For some, it's neither about religion nor health. Years ago, Pinku Kumar Goswami moved from his small village in North India to find his fortune in Mumbai. He now rummages through bins for a living, collecting plastic and glass bottles to sell to recyclers. It's a lonely job, but he's found some who keep him company. Dogs, cats, and pigeons. Pigeons are lovely, he says. If you feed them, they start recognizing you. They might even come and sit on your shoulder. In a city as big as Mumbai, it's his way to feel at home. Bacterial growth. Factors affecting growth rates. So species, nutrient type, amount, salinity, temperature, pH, and oxygen are different factors that affect bacterial growth. At too high temperature, proteins unfold and membranes become too fluid and so permeable. At too low a temperature, the membrane becomes less fluid, and chemical reactions can't get easily over their activation barrier. Each organism tailors its components so that at the temperature at which the organisms normally live, its lipid and proteins have just the right amount of dynamics to perform their function, but still retain their structure. Enzymes from extremophiles have practical uses in lab and commercially. Cell cycle. During any cell cycle, a cell must double in size. The DNA must be replicated. The chromosomes must be segregated, and the cell must divide. In eukaryotic cells, these processes are non-overlapping and occur in a strict order. Not so for bacteria. DNA replication. Structure for the bacterial chromosome. Unlike eukaryotic chromosomes, bacterial chromosomes are relatively short and circular. Like eukaryotic chromosomes, they are supercoiled and condensed. Condensation proteins include proteins that function like histones. DNA is wrapped around them. Proteins that pin together loops of DNA and topomerases. Circular chromosomes do not need telomeres, but topology problems occur during replication, i.e. overwinding and concatenation of the two replicated chromosomes. These problems are resolved by topoisomerasis that resolves concatenation problems. Gyrase is a target for some antibiotics. Identification of DNA replication proteins. Proteins necessary for DNA replication were first identified in E. coli using a combination of both genetic and biochemical techniques. Biochemical purification, in vitro assay for replication. It's cell lysate plus DNA template plus radioactive dNTPs to replication radioactive DNA polymer. Biochemical fractionation. Fractionate cell lysate into pools of proteins based on arbitrary biochemical properties. Test each fraction pool of proteins for whether it can replicate DNA. Fractionate further until you have a pure protein or protein complex. Then study the biochemical properties of your purified protein. Use genetics to identify all genes involved in replication. Randomly mutate a population of cells. Some cells will happen to have a mutation in a gene necessary for the process you're interested in. Identify cells with the phenotype you're looking for. Example, can't replicate their DNA. Clone and sequence the genes, method to be discussed later in the semester. Use temperature-sensitive mutations to study essential genes. Essential cell functions can only be studied using temperature-sensitive mutations or other types of conditional mutations. The mutant cells can be grown at low temperatures. For E. coli, 30 degrees, where the mutant protein is active and the cell is healthy. After enough cells have grown up, the cells are then shifted to the higher temperature. For E. coli, 42 degrees. By observing the first thing that goes wrong at this higher temperature, you can determine which process the mutant protein was necessary for. At longer times after the cell dies, lots of things will be going wrong. Example, the cell may lyse, macromolecules will start to break down, etc. But the first thing to go wrong after you raise the temperature will be related to the function of the protein with the temperature-sensitive mutation. Temperature-sensitive mutations typically reduce the stability of a protein structure and so cause it to unfold at moderately high temperatures. Only the temperature-sensitive protein unfolds at this moderately high temperature. It is not so hot that other proteins unfold. The assay for mutations in DNA replication genes. Add radioactive dNTPs to the media that cells are growing in. If replication can occur, the cells will incorporate radioactivity into their DNA polymers. But if a replication gene is not functional, no radioactivity will be incorporated.